Okay guys, so right now I'm going to walk you through the cow heart. So when you're looking at a heart that is bisected like this, the first step that you're going to want to do is to orient yourself. So figure out which side is left and which side is right. The way to figure this out with a bisected heart is to look for the thicker ventricular myocardium. So you can see that this is about like a third of the size of this side, which would mean that this is going to be the left side of the heart. And over here, this is also going to be the left side, as they're going to be mirrored when they close. This is to keep up the blood pressure when the blood is pumping out of the left ventricle. So when you hold up the heart to yourself, and you were to hold this side up to yourself, and keep what you know to be the left side on your left, you can see that this is going to be the anterior of the heart. And then if you hold this one up and keep the left side on your left, you can see that this is going to be the posterior of the heart. And that's going to be helpful when you are looking for certain vessels. To start with the blood flow, the place where the blood enters the heart is through the vena cava. So there are two vena cava vessels in the heart. When you're working with animal hearts, just be aware that they're called the vena cava because of the different center of gravity in quadrupeds. Sometimes they're not going to be as conveniently placed as the superior and inferior vena cava on the human heart. Just know that there are two of them, and if you label them vena cava, you will get points. On the human hearts, be aware of which one is which though. So the blood is going to enter into the right atrium, which we can see is on this side because the ventricular myocardium is thinner. And we've got these two holes right here and right here that allow the deoxygenated blood from the body to come into the right atrium, which is this chamber here. And you can see these very detailed webbed walls on the wall of the atrium, and these are called pectinate muscles. Pect means comb-like, and you can see how it kind of is like a comb, similar to pectineus or pectoralis major, muscles like that. So you're only going to see this in the atria, and you're not in the ventricles, and it's pectinate muscles. So after the blood enters into the right atrium, it passes through the tricuspid valve right here. You can see the valve tissue right here. A way to remember that the tricuspid valve is associated with the right side of the heart is that the right lung also has 3 lobes, as well as this has 3 cusps. The other way to remember that is the mnemonic LABRAT, LBRT, L for left, B for bicuspid, R right, T tricuspid. So passing through the tricuspid, the blood goes past these heartstrings, these very thin strings called chordae tendineae, and the chordae tendineae are attached to the ventricular wall through these papillary muscles. A papillary muscle is just the place where the chordae tendineae begins to thicken as they all meet in one thicker, sometimes more bulbous section of tissue on the ventricular wall, and you're only going to see them at the bottom of the chordae tendineae. There is also web-like tissue lining the walls in the ventricles as well, and you can see this down here. When it's in the ventricles, it's called trabecular muscle. So the trabecular muscle is only in the ventricles, pectinate is only in the atria. So another feature about the right atrium that you're only going to see in it is this band right here, and it's very thick in this cow heart. And this is called the moderator band. And because the right ventricle is so much smaller and with less ventricular myocardium than the left, the moderator band just assists with the conduction system and powering the muscles within the heart. And you can see this in humans, sheep, and cows in this lab. However, pigs do not have a moderator band. This one is especially pronounced, and you can see it in the male cadaver's heart this year. So when the blood, so just being clear, these are the same chamber. So the blood is within this right ventricle. Now the deoxygenated blood needs to be brought to the lungs. So the way that's going to go there is it's going to go back here, and remember that this is the anterior of the heart, so it's going to go towards the anterior, up this tube. I'm sticking my fingers down. Not get the blunt probe all the way through to show where it comes through. So as you can see, it's coming from here and coming out in here. So this is going to be the pulmonary trunk. And in order to pass through the pulmonary trunk, the blood must first go through the pulmonary semilunar valve. Make sure that you're remembering all the parts of that name, pulmonary semilunar valve. and it needs to go from the right ventricle, pulmonary semilunar valve, then it can go through the pulmonary trunk. There, which you're not able to see on here, it will be separated into the pulmonary arteries, and it will go to the right lung and to the left lung there. In the lungs, then the blood there will be oxygenated, and when you're looking at medical illustrations of these hearts, just be clear that these vessels are going to be blue because the blood is deoxygenated, but they are still called arteries because the blood is traveling away, and arteries and away both start with an A. So as long as the blood is traveling away from the heart, it's traveling through arteries, and when it's coming back to the heart, no matter oxygenated or deoxygenated, it's going to be traveling through veins. So now that the blood is in the lungs, it needs to come back into the left atrium, and it's going to come in through these pulmonary veins. And so it's been quite severed here as well, but you can still see the opening for the pulmonary veins to bring the newly oxygenated blood into the left atrium. And you can see that this one is a little bit less textured. It doesn't have as much pectinate tissue. However, you can see it on this side, on the anterior side of the left atrium. So then the blood in the left atrium travels through the bicuspid, because the left lung has 2 lobes to make room for the heart. Remember that? So it goes through the bicuspid, through all these lovely chordae tendineae. This is a great example of a papillary muscle again here, where the chordae tendineae thicken out towards the bottom and attach to the ventricular wall. This is a beautiful cross-section of a papillary muscle. And then you can see evidence of this trabecular muscle here in the left ventricle that we are now in as well, this web-textured muscle here. So out of the left ventricle, the deoxygenated blood now needs to be pumped back out to the rest of the body to supply oxygen. So it's going to need to go through this vessel, you can see right here, or this valve right here, and this is called the aortic semilunar valve. So there's 2 cuspid valves and 2 semilunar valves. Make sure you're remembering that there's the pulmonary and the aortic semilunar valve. And as the blood goes through there, it can go then into the aorta. And the aorta has several branches in this cow's heart. It can come out here and here. When the aorta turns into the aortic arch, remember, for this lab, you just need to remember the first branching vessel out of it is called the brachiocephalic, and that will bring blood up to the right upper limb and the head, and because brachio means arm and cephalo means head. Then the blood that doesn't go through the 3 branches on the aortic arch, it's going to come down and travel through the descending aorta to bring blood to the legs and lower body. So that's everything that is on the inside of the heart. Some other geographic locations is the apex down here. This center part is called the interventricular septum, just like how you have a septum in your nose. It separates the 2 ventricles. Inter means between, interventricular septum. And then here on the outsides of the heart, since this is the anterior, because we see the left side, on the anterior we can see this line right here, and this is going to be the anterior longitudinal sulcus. And this is comes from the same sulcus that you see on the brain, of where the tissue curves into a little divot point. Anterior longitudinal sulcus. Here on the outside, we also have auricles. Auricle literally means little ear, and they sit on top of the atria. So here, because we can see this is the left atrium, we have the left auricle, and here we have half of the right auricle. You can see them on this side as well, so be able to recognize that really specific tissue shape as the auricles. And that is the cow heart.